Hi, it's a real treat to be here with you remotely at the Coastal Sustainability Symposium this morning. And I'm really grateful for Chris Shank for allowing me to share a little bit about our work this morning, which is taking place down on the coast of Georgia. And I'm going to get going here with a very short presentation. And I'm focusing on a project that we have been co-developing in partnership with city and county municipal partners down in Savannah, Chatham County, and also with my co-PI on this project, Dr. Rex Clark in computer science at Georgia Tech, as well as Dr. Mildred McLean, director of the Harambe House Citizens for Environmental Justice in Savannah. So we're looking at really instrumentation and data and frameworks and networks to support equitable coastal resilience in the short and long term here in our project. And I wanted to recognize that much of our project is motivated by the fact that the communities that are most vulnerable to sea level rise and climate change are often the most marginalized and underserved communities. And that's true here in the United States and around the world. And this is just a really illustrative quote by somebody who lives and works in Africa, which is, of course, remote, very astutely vulnerable. And here in Georgia, of course, we have low-lying topography along the coast and very, very vulnerable landscapes, including this photo from the causeway connecting Tybee Island to the mainland. Also, of course, this is not even during a hurricane. This is during a king tide flooding event down on the coast. And so sea level rise has been creeping into the consciousness and disrupting the lives of people along the Georgia coastline for decades now in a relatively steady march, which has some big exclamation marks of acute flood events for the related storm surges and named storms that have come through the coast in the last decade or so, as denoted by these red bars. So those have kind of outsized significance in people's lived experience of the coastal flooding hazard on the Georgia coast. And this is data from the NOAA Fort Pulaski tide gauge on the Georgia coast of Savannah, which is the only NOAA tide gauge along the Georgia coastline. Some other classes of flooding, aside from named storms, are becoming more common. This is a photo from Russ's backyard in Savannah of a blue sky flooding event. So unpredicted, he's looking out his window at Thanksgiving Day in 2018, and this is the ocean is in his backyard, essentially. And so this is happening more and more frequently, not just during king tides, which are the classic blue sky flooding events, but also related to, in this case, a sustained wind event that came out of the Northeast and is pushing water onto the land across these communities in a very complex pattern that depends on the specific terrain and channels and things like that along the coastline, which is very complex to begin with. And of course, the wind direction compounds that complicated patchwork of flooding. And of course, on the longer term, we have to consider rates of sea level rise as an acute vulnerability as well. NOAA just released a technical report, which denotes 10 to 14 inches of sea level rise along the East Coast by 2050, and 3 to 7 feet by the end of the century, depending on the kinds of emissions trajectories that we lock in over the next couple decades. So when we step back and we realize the full threat of coastal flooding along coastlines like Georgia and South Carolina, North Carolina, and Florida, we're thinking about confronting 3 or more simultaneous stressors, each of which are accelerating with rising global temperatures. The first one, of course, is sea level rise. I just discussed. Of course, that's only going to get worse this century. And extreme rainfall has been already posing a threat to many coastal communities, also noted in the IPCC report, increasing with warming rates going forward. And stronger hurricanes also noted to worsen with climate change along these vulnerable coastal communities. And so when you take these together, you have to understand each one of them in and of itself in terms of what drives it and how it shows up on the coast, but you also have to think about how they show up together, because increasingly these are compound events, which are pile-ons, if you will, of several of these stressors. And so these impacts pose a current threat to communities, and it's not just infrastructure in people's lives and livelihoods, but it's also about the regional economy the national security, and of course, the fact that they are acutely, some communities are more vulnerable than others, and are, of course, examples of the kind of systemic inequities that are worsening with climate change impacts. So enter Smart Sea Level Sensors. It's about a 4-year-old program, and it's based on the development and deployment of, you can see the sensor up there on the upper right, the kind of a shoebox size ultrasonic based sensor technology, and it's very low cost. And we have dozens of these installed on the coastlines. And this is really grounded in deep partnership between Georgia Tech, city and county officials, as well as this Harambe House, Citizens for Environmental Justice, a local NGO. And so we're focused on providing real-time data. We're also using that in a flood forecasting sense to develop models to predict flooding 3 or more days out. And we're thinking about the longest term, decades long process of building resilient communities along the coastline and developing planning processes that reflect the immediate needs as well as the longer term needs. We have a very large nexus of partners that I'm so grateful have been champions for this work and have enabled us to get where we are. And I'm not too many to name here, but as you can see, they actually stretch across the oceans as well. We have 55 sensors installed across Chatham County right now, and this is a map of those sensors. You can access dashboard.sealevelsensors.org and get a very good sense for what we're trying to do with this sensor network data in terms of providing it to the public and allowing people to browse through it. And I wanted to note, especially relevant for this discussion today, that NOAA has funded an expansion of these low-cost water level networks across the Southeast United States. And you can see the kinds of academic partners that are leading different regions of this effort. Of course, we are happy to be funded to expand our network down the Georgia coastline. And so these sensors are built from off-the-shelf inexpensive parts. They're powered by D-cell batteries or solar cell. They use a LoRaWAN communication protocol, which talks to a gateway that I'll point to in just a minute. And this is a student from Jenkins High School located in Savannah assembling the sensor, and they've been amazing partners in helping us get 30 or more sensors built over the last couple years. And the gateway device is what these sensors are relaying data to, and that gateway device is, of course, shuttling that data back to servers at Georgia Tech. These are quite a bit more pricey, but you only need one to serve a 1 to 4 mile radius, and they can serve hundreds of different sensors because these are low data rates. And the good thing about this is that once you put this infrastructure in place, it's owned by the city and the county, and it's essentially free to them. You don't need to pay communication costs and things, et cetera. And this can provide a backbone for Internet of Things services beyond these specific sensors, for example, temperature, or humidity, or air quality, or even traffic sensors, whatever the city or the county may see fit to deploy. And so we've benchmarked our water level sensors with the NOAA tide gauge here in this plot, and we have many months of data now that help us understand that these sensors are doing a fabulous job at recording water level that with accuracies of less than 1 inch over these timescales. So we're working on a publication to get that out. The main thing we're trying to do is lift up decision support tools for our key stakeholders at the city and the county level. Listening to what they wanted, the first thing they wanted was a public data portal. I already mentioned that, dashboard.sealevelsensors.org, where people could access the data from these funny shoeboxes and understand what's going on in their neighborhood and how it compares to, for example, to Fort Pulaski. Emergency planning portal, we just finished this year, which allows emergency planners and responders to access really specific information from a sensor, from the network of sensors, thinking about overlays for critical infrastructure like bridges that will help them deploy limited resources in a state of emergency. And then last but not least, developing a 3-day forecast system to try to provide information out several days to communities that are under threat of flooding so that, of course, you can prepare planning accordingly. This is an example of some of the dynamical modeling tools that are under development right now. This is work by Emanuele Di Lorenzo at Georgia Tech. And you can see the Georgia coastline in the upper left, kind of nested into this high resolution model that flows up into the channels and the tributaries along the Georgia coastline. And this model actually goes down to a 10-meter horizontal resolution. And you can see the modeling of the Savannah River there kind of zoomed in, providing a kind of urban scale flood tools to understand where the water will be during a flood emergency, and also helping us to understand in hindsight how the data from this kind of modeling framework compares to what actually happened on the ground, for an example of Hurricane Matthew here. So you're looking in a hindcast mode at comparing model and real data that happened during a flood disaster. Last but not least, I wanted to lift up the work of some of our social scientists who are using a tool called the Map Room to elicit the input of local experts into our research framework. Their lived experiences, their priorities, the assets that the communities have at their disposal for resilience, and what they might want going forward. So this is a process that's an interactive, digitally based framework. And here you can see Dr. Milton McLean, in fact, using the Map Room down in Savannah. And we've also been working very closely with the Gullah Geechee community at Pinpoint down in Savannah as well. This is a community with unique cultural heritage and really unique needs and desires when you think about resilience, both in the short term and long term. So happy to have them as a new partner this year, and looking forward to exploring what kinds of infrastructure and processes and planning tools they might like to have co-developed with researchers at Georgia Tech, UGA, and Savannah State. So last but not least, I just wanted to recognize the IPCC Working Group 2, really calling for, in their adaptation vulnerability analysis, an inclusive planning framework that's informed by cultural values, indigenous knowledge, local knowledge, and scientific knowledge, so that we can have optimal adaptation to what we know are a growing set of threats and risks. And so our approach has been to lay a sustained foundation for this work that explicitly is multi-sector from day one, is building to intergenerational capacity, thinking about the K through 12 environment, up to and including the elders who I just showed from the Gullah Geechee community, who can help guide this work and transfer knowledge across generational lines. Transdisciplinarity is key. We have to work across so many different disciplines and sectors to get this job done. And last but not least, our work is grounded in justice, equity, diversity, inclusion, recognizing that these most vulnerable communities are the communities that we must serve first. And with that, I will stop sharing and end my presentation. Thanks so much.